What about looking at the cell-to-cell signaling in blood? Has anyone done that to look for like exosome production, from white to red, from red to white? What's the other analysis?
Yeah. So once kind of that lineage that I mentioned, so you have this master hematopoietic stem cell, it differentiates into these progenitor cells, which then differentiate into more committed cells. So what you're alluding to is kind of the ability to go across lineage, right? To go from white blood cells to red cells to platelets. And the only cell that can do that is the hematopoietic stem cell. The progenitor cells, in other words, myeloid progenitor, lymphoid, is the first separation into that tree. They can actually make different types of cells, but the further along you go, the more differentiated as a cell you become and the less likely you can, become something else. Having said that, there's the field of looking at pluripotent stem cells or inducible pluripotent stem cells, iPSCs, which is incredible because you can actually take a skin cell, for example, and potentially change its lineage outside the body for it to become another type of cell. But that's, again, something outside of hematopoietic stem cell transplant.
What about the platelets? What role do they play? Are they created, by the bone marrow, or are they created somewhere else? And how do they relate to the concentrations and availability of white and red cells?
Yeah, so they too derive from the hematopoietic stem cell. So they have a certain chemical called thrombopoietin. That's that cytokine that I mentioned that stimulates or taps the hematopoietic stem cell on the shoulder and tells it to become a platelet. So thrombopoietin is that type of cytokine. Erythropoietin is the cytokine that stimulates the stem cell to become red blood cells. And then the GCSF that I mentioned in the stimulates the stem cell to become white blood cells.
Okay. But what role do the platelets seem to play or even the cytokines themselves? I mean, it is a large amount of cytokine of one kind. Does that suppress the production of other cytokines, or do the cytokines do signaling that, again, outshouts the other signaling from other cytokines? Like, who has played with the dynamic of all the constituent parts of the blood to make it do X, Y, or Z?
Yeah, so that's a great question. So there are lots of different chemicals floating around in our bloodstream. And the reason why we survive is because we have this fight and flight mechanism, right? So it's sympathetic and parasympathetic nervous system and discharge. The same thing in terms of the way our body responds to challenge, environmental challenges. So for example, infection. So when we get a cold virus, that's stimulating our immune cells in order for them to do a couple things. One is to produce some of these cytokines, which stimulate other cells to come along. So that's called recruitment, to attack the virus. It also kind of stimulates the progenitor cells to make more of these cells. So that's production. So you have recruitment and production. And then you have elimination of the virus, because some of these chemicals can actually directly target the virus as well. So at any given time, we kind of maintain this state of homeostasis. In other words, we have everybody ready to the call to action should there be kind of an invasion of our bloodstream through a virus. But we also don't want to overreact, right? Because if we constantly had reaction going on, then we would actually start to attack ourselves. And some people actually have that problem. It's called autoimmune disease. So that the immune cells are attacking certain parts of their body, like, for example, Crohn's disease or inflammatory bowel disease. Those patients don't have cells to quiet the immune cells, and it causes an autoreactive loop to occur, and so they have inflammatory bowel disease from it. So back to your question, is there are many chemicals floating around our bloodstream that tell the body, at least the progenitor cells and the hematopoietic stem cells, to either kick in because we need your help. There's like infection here, so you got to become another cell real quick, or we need you to quiet down because we can take care of things and we don't want it to become a riot in the bloodstream. So you kind of have these police cells to maintain order in the body so that you don't get autoimmune disease, for example.